without further ado, let's begin. So second derivative, what is the function? So second derivative is for the measure of concavity. So here, the measure for the concavity of the graph of f function whose second derivative only, okay, second derivative only is positive, will be concave up. So positive after second derivative will concave up, and negative will concave down, meaning that the tangent line will lie below the graph of the function for concave up. Okay, so how do you find the second derivative? The second derivative of an implicit function can be found using sequential differentiation of the initial equation f in bracket xy is equal to 0. At first step, we can get the first derivative in the form of y prime f1 xy bracket. On the next step, we can find the second derivative, which can be expressed in the term of variable x and y as y double prime f2 xy bracket. Okay, so I'm gonna show you more detail in the example given. So given example 2 here, given the question is y is equal to x squared plus exponent sine x. The question is find dy dx and d2y dx2. So rewrite the question, y is equal to x squared plus sine x, dy dx is equal to 2x. So 2 here, wait a second. Okay, so 2 here, Allah, sorry. So 2 here, bring in front. So got 2x and 2 minus 1. So we get 1 power. And then for exponent, we use the formula exponent x times exponent prime. Exponent prime is this one, cos x, and exponent x is equal to exponent sine x. Okay, so to differentiate double time, we found out that this here, right here, okay, have two apa ni? Sorry, have to have two brackets right here. So we can calculate this is fx and gx. Substitute with the formula given. You need to remember this formula. Find fx, f prime, gx, and g prime x. And then just substitute. And then you will get the second derivative of this question. So just simplify after we get after you substitute this value, after you substitute, the second one is you need to simplify it. So both this have exponent sine x. So substitute this and this one to outside of the function. So at the end, simplify second derivative, you will get 2 plus exponent sine x bracket cos squared x minus sine x. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. So my name is Muhammad Ifa Ashraf Behami. I am from AS102J, and today I am going to present my topic, which is implicit differentiation. So what is implicit differentiation? Implicit differentiation is that we differentiate each side of an equation with two variables, which usually x and y, by treating one of the variable as a function to the others. So this is called using the chain rule. So in the equation, usually we choose x or y to be the variable of each other. So if we choose y to be the variable, y is the function of the x. If we choose x, so x is the function of the y. So we are going to proceed with the example. So the first example is x squared plus y squared equals to 1. So what we are going to do is differentiate both sides. So differentiate x squared will be 2x. Differentiate y squared will be 2y. But in implicit differentiation, we choose one of the unknown, which is y, to be the function of x. So we put dy dx. So if the equation in the equation have y unknown, we put dy dx. So next step, we make dy dx as a subject. So we are going to rearrange the equation. So it will be just like this. Dy dx equals to negative 2x over 2y. So if we factorize this, so the last answer is dy dx equals to negative x over y. So there's another example. Okay, so for the second example is x squared plus xy plus y cubed equals to 0. So what we're going to do is the same. We differentiate the both sides. So differentiate x squared, it will become 2x. Differentiate xy, this we're going to use the derivatives of product because they have two unknown times together. So first we differentiate x equals to 1 and we let y, we keep it the same, plus differentiate x, we keep x and differentiate y. So differentiate y equals to 1, but in implicit differentiation, if we choose one of the function, we put dy dx. So y here there is no dy dx because y here we let the same and y here we differentiate. So there is dy dx. So right here, y cube we differentiate, it will be 3y, and dy dx because we differentiate y as well. So 0, we differentiate 0 is still the same 0. So next step is we rearrange the equation, make dy dx subject in the left side. So the last answer will be dy dx equals to negative 2x minus y over x plus 3, as you can see in this solving problem. So that's all for today for this subtopic. So thank you.
Hi, my name is Muhammad Ibrahim Shazwan dari ID. I am from class AS1202J. My ID number is 2019239128 and I will present about tangent line.
So now I will talk about tangent line. So as introduction, calculus is a branch of mathematics that deals with rates of change of a quantity. For example, a car speeding down the street, the inflation of currency, the number of bacteria in culture, and the AC voltage of an electric signals are all examples of quantities that change with time. In this section, we will study the rate of change of a quantity and how it is related to the tangent lines on the curve. So, there are two objectives in this learning. So, the first one is to understanding the rate of change of a function. The second one is to understanding of the slope of the tangent line to the graph. So, what is tangent line? So, the tangent line is a line that touch the graph of the function at the point and it is parallel in some way to the graph at that point. As example, so you can look here. This is a line and there is another line. This line is parallel to this line. So at the point the line touch the graph touch
the line, the parallel line. So this is called as tangent line. So here is tangent line. This this point is not a tangent and not a tangent line here. So the question wants us to find equation of the tangent line. So the question gives us equation of the curve y equal to x squared minus 2x plus 3 and the point 2, 3. So first we must, from the equation of the curve, we must differentiate it. So we get dy dx equal to 2x minus 2. So then from the point given, we can substitute the x, the value of the x here, we can substitute into 2. So the gradient of the curve, we get 2 multiple 2 minus 2. So we get 2. The answer is 2. So the gradient of the curve is 2. So here is the formula that we use. Gradient equal to y minus y1 over x minus x1. So from this formula, we substitute the value of gradient and the value of y1 and x1 from the point given. So y minus 3 over x minus 2 equal to 2. So we bring x minus 2 here to the other side. So divide will be multiple. So we get the final answer is y equal to 2x minus 1. So we go through to problem statement 2. The question is, find the slope of the tangent to the curve y equal to sine 3x over ln x minus x plus 1 minus 8 at x equal to 0. So the question wants us to find the slope of the tangent, and the question gives us 2 points. First, the equation of the curve y equal to sine 3x over ln x plus 1 minus 8 and the point x equal to 0. So as same like the problem statement 1, we need to differentiate the equation of the curve. So we use this method, fx equal to fx over gx. So f prime x equal to gx times f prime x minus g prime x times f prime fx over gx squared. So here, from here, so we get dy dx equal to ln x plus 1 minus 8 times 3 cos 3x minus 1x over x plus 1 times sine 3x over ln times x plus 1 minus 8 squared, the power of 2. So at the point 0 x equal to 0, so we get the gradient or the slope, we get ln times 0 plus 1. So we substitute here 0, x equal to 0, so ln x equal to 0, 0 plus 1 minus 8 times 3 cos 3 times 0 minus 1 over 0, here substitute 0 plus 1, times sine 3 times 0 over ln times 0 plus 1, here substitute 0 here, minus 8. Let's correct here. So then the final answer we will get negative 3 over 8. So this is the final answer, the gradient of the tangent line, the gradient of the tangent. So